This is section 4.1, number 11. It says, assume the population grows exponentially with a constant annual percent increase, R. The population of a city was 1,786 in 1990. Write a formula in terms of R for the population of the city T years later. Okay, so we're going to write this equation of the form P of T is equal to P naught times B to the T. But notice that B is comprised of R, the growth or decay rate. In this case, because it's growing, we're going to say that B is equal to 1 plus R. So altogether, we have P naught, the initial population, times 1 plus R to the T. So in this case, P naught is 1,786 times 1 plus R, and then to the T. And then in part B it says in 2000 the population was 3,513. Write an equation and solve for R. What was the annual percent increase? What we see happening is in 2000, which is 10 years later, so when T is 10, the population was 3,513. So what we could do is replace in the formula that we created in part A, we can substitute these values. Okay, so P 3513 is equal to 1786 times 1 plus R, and then to the T, which is 10. And we want to solve this equation for R. By hand, I can divide both sides by 1,786. Your goal is to isolate that power. So we have 3513 over 1786 is equal to the quantity 1 plus R to the 10th. And this is kind of like if you had 1 plus R squared, you would take the square root of both sides. In this case, we'd take the 10th root of both sides. But another way to write that is to raise both sides to the 1/10 power. So on the right-hand side, we have 1 plus R by itself, and then on the left-hand side, this new power, 3513 over 1786 to the 1/10. And lastly, I would get rid of the 1, and we would do that by subtracting 1 from both sides. And so we have R equals the quantity 3,513 divided by 1,786 raised to the 1/10, and then minus 1. Okay, enter this expression on your calculator, and we get a decimal approximation of about 0.06999. Hey, however, written as a percentage, I would multiply this number by 100, and we get 6.999. Now it also says round to the nearest hundredth of a percent, and so that's the second place. And altogether, we would end up rounding this entire number to 7.00 or 7%. Okay, so solving the equation by hand can be a little intimidating, and so here's another option if you prefer. Just enter in Y1 the expression for the population after 10 years, and then in Y2 enter the population and graph. And so I'm going to try the standard viewing window, which is zoom 6, and then zoom 0, which is zoom fit. And so where that line and that curve intersect is what I'm looking for. So I'm going to use the intersect feature, that's second trace, option 5, and then hit enter 3 times. And here is that X value that we found, which is really R, a rate of increase.